Hello everyone, welcome to SSJB's Mentora. In this lecture, we will discuss about the poles and zeros. Now, in the previous lecture, we have discussed about the Z transform, how to find the Z transform of any given signal or the given sequence. Now, let us see how to find the poles and zeros and what is the exact need of poles and zeros to find the stability of the system. Let's see. Now, if I want to revise the LTI, what is it? It's the linear time invariant system. The input to that system, which is having h of n as impulse response, the input to it is x of n, and its output is defined as what? The y of n, which is simply the convolution of x of n and h of n, because it's in the time domain. Which domain? It's in the time domain. But as we have shifted into the frequency domain, we will be dealing with the Z transform. Okay, now let us consider in the Z transform. This is the time domain, and for, let's say, I am having the x of z as the input to the system, which is having the h of z as the impulse response, or after that we will call it as the transfer function. But let us consider for the similarity as the impulse response for the Z transform or the frequency domain. This is for the domain freक्वेंसी डोमेन में अब जब हम वर्क करेंगे, h of z होगा कुछ हमारा impulse response, output will be y of z something, y of z. Now tell me one thing, we have revised, we have learned multiple times that the convolution in time domain is multiplication in frequency domain. उसी हिसाब से अगर देखा जाए तो y of z is x of z. कन्वोल्यूशन नहीं होगा, सिंपल मल्टीप्लीकेशन होगा विथ व्हाट? h of z. Okay, y of z is equals to h of z into, not the convolution, not else operation, it's a simple multiplication into with the h of z. Now if we rewrite this term, okay, it's a y of z is equals to x of z into h of z. You can get that h of z is equals to y of z upon x of z, and this is nothing but the transfer function. What is this? This is the transfer function. Transfer function. Why transfer function? Because it's a ratio of output by the input. Okay, it's not important that output upon input is the transfer function h of z, but the important here to understand this upper part, the numerator part, denotes the zeros of the given system, and lower part, the denominator part, the x of z, denotes the poles of the system. Zeros and poles, we denote the zeros by simple zeros and poles by this. Okay, let us take example. If I am having any simple circle here, okay, and this is, let's say this is A, and with some equation given, I got this kind of representation. With that, I can represent the zeros according to that equation. Okay, let's say I am having 1 0 at the 0 only, 1 0 at A. Poles, let's say at some different position. Let's say I am having pole at this position or any other position, this position, imaginary and real part. Okay, तो अगर मैंने इससे एक यूनिट सर्कल कंसिडर किया, नाउ दिस थिंग्स विल बी गेट मोर क्लियर वंस वी स्टार्ट द डिस्कस, विल डिस्कस द example on the poles and zeros. This is just the representation y of z upon x of z, but just one thing, poles and zeros will be depend on value of z. We need to convert the given equation in this form, y of z upon x of z, and according to that, the upper part, by simplifying the upper part equation, we will get the zeros, and by simplifying the lower part equation, we will get the poles. Now next important thing is how to define its stability. If I am having any unit circle, let us consider here only, we will discuss here only. I am having this circle, okay, I am having this circle only, and let's say this is the A is equals to 1, let's say it's the unit circle I am considering, okay? And if the poles of the given system lies in between the A, if the poles are less than 1 or the given A is just for the example, okay? We will be having any A value. A can be anything. Let's say 5, 6, 10. Anything can be there for the A. It will depend on the given example only. But the poles are less than that. Means the poles are lying inside the circle. If the poles are lying inside the circle, I will write here. If poles are inside the circle, inside the circle, not the unit step. It is not necessary that the circle will be always having the magnitude 1. It can be having any magnitude, okay? But the important is the poles. If the poles of that system are inside the circle, then the system is stable, okay? This is the condition for stability. What is this? This is the condition for stability. And what is it? That simply, if I am having any circle, the poles must lie inside that circle. The poles must lie inside that circle. If it is outside the circle, that system will be unstable. Unstable. Okay, that system will become unstable. This is the simple condition, and it will be get more clear once we will discuss the example.